Welcome back everyone. Let's learn what is GCF and how to use GCF to factor out the polynomial expression or polynomial equation. This will also help us with factoring the polynomials. What is a GCF? GCF is the greatest common factor. As the name suggests, our first objective should be to find the common factors, and from the common factor, whichever factor is the greatest, that would be our GCF. So there are two preferred ways to do this. The first way is, if you are good with multiplication and you know your factors very well, go ahead and write the factors. And I write them always in the ascending order. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and always the number itself. Why am I including 1? Because sometimes the number do not have any common factors, and in that case 1 would be our GCF. So for 15 we have 1, 3 and 5. Sorry, 5, not. It would be 5 and always the number itself. So 15. I can see that the common factor here other than 1 are 3. Since 3 is greater than 1, it is also our greatest common factor. So the GCF here is 3. What is another way of solving this problem, finding the GCF? Another way, this way usually works when we don't have enough practice with the multiples or factors. You can go ahead and break apart your 24 into its prime factors. So what I can think of is 24 is 1 times 24 and 3 times 8, and 8 would be 2 times 2 times 2. And remember, when you are writing in the prime factors, it should always be in the ascending order of the factors. So I will start by writing ascending least to greatest. 1 times 2 times 2 times 3. Let's write the factors of 15. So for 15, I'll just have 1 times 3 times 5. And now we will find the common factors and multiply them. So just to show you how GCF works in this way, we will choose the common factors, all the common factors, and we will multiply them. So our common factors here are 1 and 3. So the GCF again is 3. So it doesn't matter which way you choose to do this, it will still come out as the same answer. Let's see what happens when we are working with the variables, just the letters. Again, two methods of doing this. So the first method is you take your variable and you can break it down into the factors. The factors of x to the power of 4 would be x multiplied by itself 4 times, and the factors of x to the power of 2 would be x multiplied by itself 2 times. Remember, the process would be the same. You will find out the common factors and you will multiply those common factors. So I have, remember, we are only choosing one from each set since they are common. So our GCF would be 1x from the first set and another x from the second set, which will give us x to the power of 2. Another method is just a trick. When you have letters, first find out if they are common. If they are common, you just go ahead and choose the one with the smaller power. So from x to the power of 4 and x to the power of 2, I can just simply go ahead and choose the smallest of 2 and call it my GCF. Let's do another example to practice this. Here I have 3 terms: a squared b cubed, a cubed b square, ab x. So if I apply my first method, I can simply break down my a squared b cubed, a cubed b squared, abx, find the common factors and multiply them. But for the variables, I like to go by the smaller trick. And what is that? First, make sure you write down all the common factors. Now common factors are the letters which are in all three of the terms. So find out all common factors. Now what are our common factors or the common letters here? I can see I have A in all three terms. I also have B in all three terms. Is X present in all three of them? No. So X will not be a part of our answer. X will not be part of our greatest common factor. The next thing we will do is we will choose out the smallest power. So the smallest power of A in all three terms is 1 and the smallest power of B is also 1. So my GCF is A times B. All right. So now let's apply this information and solve a question which has both numbers and variables. So I have two terms here, negative 12 x squared b to the power of 4 and 30 times x b to the power of 2. To keep it simple, I will go ahead and break down my number into its prime factors. You can see that I include 1 also. 12 is 3 times 4, but 4 could be written as 2 and then x squared and b4, I will keep it exactly as it is. Next is 30x b squared. Again, 1 times 30 is 3 times 10 and 10 could be written as 2 times 5. You will see that I am arranging everything in the from least to greatest. And I will write down my letters as it is. Now let's figure out the common factors. I can see my common factors are 1, not negative 1, just 1. I can choose to include 1 or I can choose to ignore 1 in this case. So my common factors are I have a set of 2 and I have a set of 3. So from my numbers, I will go ahead and write each from the set. So I will write my 2, 1, 2 from the set. I will write my 3. Now let's move on to the letters. First, make sure that the letters are common. So I have to check, do I have X in both of the terms? Yes, I do. Then I'll go ahead and choose the smaller power or the lower power of X. So out of X squared and X, the lower power is X or X to the power of 1. And I'll do the same thing with B. Since we have B common, I'll go ahead and write B. And what is the lower power of B in those two cases? B4 or B squared. So B to the power of 2 or B squared is the smaller power. And our GCF in this case is multiply 2 and 3, 6x b squared. All right, another practice problem. So GCF of 121. You can also pause the video and try finding this one by yourself. Go ahead and write down 121 into its prime factors. For the letters, I am not breaking them down. I will just write them as it is. And then we have 33 m squared n a. So 33 can be written as 3 times 11 m squared n a. Now let's write our GCF. So my GCF would be, let's look at the numbers. From my numbers, I only have one common factor, which is 11. Now let's take a look at our variables. Do I have m common? Yes. And which one has a lower power or the smaller power? So m to the power of 1. From n, I have n to the power of 1 again. But then I don't have a b in my second term and I don't have an a in my first term. So a and b will not be included in our GCF. So our GCF in this case is 11mn. That's our GCF. We have discussed how to find out the GCF. Now we will practice how to factor out the GCF from the polynomial expressions, algebraic expressions. 4t plus 12. First look at your numbers. What is the GCF of 4 and 12? The GCF of 4 and 12 is 4. And do I have a common variable? A common GCF for the variable letter t here? I don't have a t common in both of the terms, so t will not be included in my GCF. Once I figure out my GCF, I will write it outside of the parentheses. Now I need to divide my GCF with each term. So if I divide 4t with 4, it leaves me with t. I will go ahead and write t in my parentheses. And then if I divide 12 with 4, it leaves me with 3. And since there is a positive sign in the middle, I'll go ahead and put this sign. So this is called factoring out the GCF. Let's try next example. Y to the power of 8 and y to the power of 4. Remember, we have discussed this when it comes to the variables. If the letters are common, if the variables are common, we choose the lower power or the smaller power. So y to the power of 4 is my GCF. Let's go ahead and divide y to the power of 4 from each term. If I divide y to the power of 4 from y to the power of 8, so I think of it like I need 8 powers. I already have 4 of them. So how many are left? That's how I like to think. So I can have 4 more. And from the second term, you have 4 powers. And you have y to the power of 4 as GCF. So how much is left? Which can also be written as y to the power of 4 divided by y to the power of 4. This will just give us 1. So if you factor out y to the power of 8 plus y to the power of 4, this is how it looks like. Let's do next example. So from the numbers, my GCF is 6. And let's see if we have any common variables. So a is a common variable. The smaller power of a is 1. My GCF is 6a to the power of 1. So from my first term, 6a to the power of 4, if I divide this with the GCF, from the numbers, I just have 1 left. And from the variables, I need 4 powers. I already took out 1. So a to the power of 3. And then for my second term, if I divide that with my GCF, I will only be left with 2. So a way to check is, once you get your GCF, once you factor it out, to check if your answer is correct or not, you should go ahead, distribute and multiply. If you get the same thing back, like in this instance, when I multiply my GCF with the terms in the parentheses, the factored out terms, I see that I get the same term back. So I can check with this.